Good morning, everyone. We are Group 6, and today we're presenting a deep dive forensic investigation into Case 2026-03 titled Project Nova, and our team, Sachin, Tisha, Darsina, and Poisun, will demonstrate how we utilize the scientific method of digital forensic to solve a high-stake case of copper espionage involving an insider threat. Our case focuses on an internal security breach at NovaTech Corporation. We identify a senior developer, Alex, who attempted to exfiltrate proprietary solar cell optimization algorithm following a contract termination notice. The incident involved premeditated reconnaissance exfiltration via unauthorized removable media and a calculated attempt to frame an external hacker using a red herring strategy. As we will demonstrate, our forensic approach successfully invalidated these deceptions. To provide context, NovaTech Corporation is a premier sustainable energy R&D firm, and their entire market value is driven by intellectual property, and this investigation centered on Workstation 01, an environment that was high value but lack of technical endpoint controls necessary to prevent a privileged user from moving sensitive data to external devices. The crown jewel of this heist was the Nova algorithm, a proprietary conversion logic valued at over $4.2 million because the source code was stored in plain text format for developer reference. It presented a low-friction target for theft, and the loss of this asset would have granted a primary competitor an immediate and unfair technological advantage in sustainable energy sector. Alex's strategy involved exfiltrating data via a physical USB driver planting putty, a network tool, to create the illusion of a remote SSH breach. He hoped investigators would chase an external hacker while he walked away with the code. I will now hand over to Sachin to explain how we professionally preserve the crime scene.
Thank you, Aisha. To ensure forensic reproducibility, I established an isolated lab using Oracle VirtualBox to host the suspect's Windows 10 environment. We allocated 4 GB of RAM and 30 GB of storage. Crucially, the network adapter was set to not attached. This frozen environment ensured that no cloud updates or background syncs could alter the system metadata or overwrite temporary logs during acquisition phase. Adhering to the golden rule of forensic, to never work on original evidence, we performed a bitstream acquisition using Exterro FTK Imager. Unlike a standard file copy, this bitstream captures includes every physical sector, including unallocated space where deleted data resides. We exported the evidence in NK's E01 format, segmented into 1.5 GB fragments to ensure portability while maintaining forensic-grade metadata. Integrity is our mathematical guarantee. While FTK performed initial checks, I implemented a defense in-depth verification using Windows CertUtil utility. The SHA-256 digital fingerprint you see here, ending in E77E, matched our acquisition hash perfectly. This proves that our evidence is 100% identical to the state in which it seized and is fully court admissible. I will now pass it to Tisha to begin with the search of artifacts.
Thank you, Sachin. I began the search in autopsy by looking for the mens rea or guilty intent. By analyzing the Age History SQLite database, we found that at 20:24 p.m., Alex searched for how to steal data with USB. This artifact is definitive. It establishes that the subsequent theft was a premeditated act, not a routine file transfer or an accident. Moving to proof of access, we examined the recent items folder. Even though Alex deleted the confidential file, the Windows shell automatically generated a LNK shortcut file when he opened it. We recovered confidential algorithm txt LNK with a timestamp 20:20 p.m. This metadata proof Alex didn't just possess the file. He actively opened and rendered the source code on his screen. To identify the physical path of the theft, I conducted registry forensic on the USBSTOR key. We identified a Kingston Technology flash drive with a unique serial number ending in 89. It was recorded as last connected at 20:49 p.m., providing us with the exact physical medium and the window during which the data left the system. Darsina will now reveal the smoking gun found in the unallocated space.
Thank you, Tisha. This is the definitive proof that closed the investigation.
Despite the suspect emptying the recycle bin, I performed data carving on the unallocated clusters. We successfully recovered the R resource file as shown in the text view on the screen. The content was still intact, revealing the secret source code 998877. This recovery directly links the suspect's user profile to the stolen intellectual property. We have also identified a clear consciousness of guilt. Our timeline analysis revealed a distinct 30-minute blackout in the browser history, immediately following the USB exfiltration. Furthermore, the presence of isolated metadata files in the recycle bin without corresponding DR data files proved that Alex issued a manual empty recycle bin command to destroy his digital footprint. We also debunked the red herring distraction. We identified the PuTTY installer Alex downloaded to frame an external hacker. However, our timestamp analysis reveals the downloaded occurred after the data theft was already complete. This chronological mismatch exposed the download as a staged event intended to frame others, but the forensic timeline revealed the truth. As you can see from our reconstructed timeline, the entire crime took only 32 minutes. From the file creation at 2019 to the file cleanup at 2051. The speed and precision of these actions indicate a determined insider acting with extreme urgency. Poison will now conclude with our recommendation and compliance summary.
Thank you, Tassina. We have broken down the failure into 3 clear categories. 50% was the technical failure due to the lack of USB blocking. 30% was an administrative failure as Alex was granted excessive local admin's right that allowed him to attempt anti-forensic. The final 20% was human factors. The organization failed to monitor high-risk behavior during a termination period. To prevent a recurrence, we recommend major technical control. First, implementing USB whitelisting via group policy to explicitly block any unauthorized storage IDs. Second, the deployment of data loss prevention or DLP software, which perform real-time content inspection to flag and block the movement of files containing confidential keyword. Administratively, NovaTech must enforce the principle of least privilege. No developer should have local administrator rights. Furthermore, we suggest a risk-based offboarding SOP where system privilege and USB access are immediately revoked or audited the moment a termination notice is issued to high-value IP holders. Our investigation adheres to the highest professional standard, summarized in the matrix on your screen. We ensured evidence isolation through graceful shutdown. We achieved high-fidelity acquisition through bitstream imaging to capture unallocated clusters. We guaranteed integrity through SHA-256 hashing, and we perform deep analysis through data craving. The matrix proved our investigation meets legal standards for court admissibility. In conclusion, this case highlights that digital truth is persistent. While suspects may attempt to wipe their tracks, forensics can illuminate the truth left in unallocated space. This investigation serves as a blueprint for shifting from implicit trust to a zero-trust architecture. We have successfully proven the case against the insider. That concludes our presentation for Group 6. We have resolved case 2026-03. Thank you for your time.